Good afternoon. I'm Ravi Shankar Gadam, EDA Design Methodology Manager at Allegro Microsystems, responsible for EDA tools and design methodologies. The focus of my team at Allegro is to analyze existing design methodologies and enhance them to improve design teams' efficiency. Today in this topic, I'll be talking about achieving ROI on IP management. I'll go through the need for a formal approach for IP management and the ROI with the IP management system. For those who don't know Allegro, a quick introduction. We are a global leader in sensing and power IC solutions and number one in magnetic sensing ICs. If you look at the sales by product, 62% of our sales come from magnetic sensing and 38% from power ICs. And by market sector, 73% of our sales come from automotive, 21% from industrial, and 6% from other markets. We have a very rich history and 100 years legacy of innovation with purpose, as we serve more than 10,000 customers, hold greater than 1,900 patents. And as of March 2024, end of FY24 fiscal year, we have around 4,600 employees currently. Allegro has a strong track record of financial performance. We went IPO in 2020, and in the last fiscal year, our sales crossed 1 billion mark with 8% increase compared to previous year. Allegro products are everywhere. You can name them. You can find them in e-mobility, clean energy, and automation. Our sensors and power ICs extend the range of electric vehicles, reduce power loss in energy system, and keep data center servers quiet and cool. So what does Allegro do, or what does Allegro products do? Allegro makes three types of products: sensors, power regulators, and drivers. I'm going to walk you through the use of these products using a simple electric power steering, aka EPS, of an automobile as an example. Allegro builds magnetic sensors that typically help sense speed, direction, motion, movement, and even help measure the flow of current. In a power steering system, the EPS controller controls the steering of the vehicle for safety and autonomous driving based on the inputs from a 360-degree angle sensor as well as torque sensor. Now that same EPS controller needs power regulators. Power regulator ICs at typical battery voltage is 12 volts, and many of the ICs run at 5 volts, 3.3 volts, and 1.2 volts. So for that purpose, you need a robust, reliable voltage or power regulator IC, aka power management IC or PMIC, which Allegro is well known for. And finally, in the same EPS system, you can think of the motors that are used to control the mechanical system. These motors need to be driven smoothly, quietly, without jerks. And this is what Allegro's motor and gate drivers portfolio does. So anywhere there is a motor in any fan or a pump, you can think of Allegro driver being used to drive those motors. I know I've talked about developing the best products in the market. To develop these products, we also need to follow a formal approach, which includes the IP management system. And what does the IP management system need to provide? First thing is the documents and traceability requirement. And as you know, Allegro is a manufacturer of automotive semiconductor IC. We follow and comply with the ISO 26262 standard. A proper documentation and traceability makes it much easier for us to meet this requirement. Next is faster time to market. We have to deliver products to support the growing need and also to be competitive in the market. With the ability to use a predefined, verified IP, it significantly reduces our development cycle. Next is the reduced cost and risk. Each IP that is already verified provides the leverage to use at no additional development cost and testing cost, and at the same time reduces the risk. Next is the enhanced design efficiency. Designers can be more focused on integrating and customizing the existing IPs instead of redeveloping the same IP, which indirectly or directly helps them to improve their design efficiency. Improved quality and reliability. Reputable IPs that are well tested and documented provide higher design quality and reliability of the final chip. Finally, the scalability and design flexibility. The larger the number of IPs available, the more easily engineers can pick and choose the functionality at a given time, providing them that great flexibility and scalability when they start working on their projects. And to solve these challenges, the solution is to store and publish IPs. For that, we have Keysight HUB platform. HUB provides us ways to store IP and publish them. And within the system, we can differentiate IPs as corporate IPs and community IPs. The corporate IPs are special IPs that are developed by dedicated IP teams. For example, an EEPROM that should be used as a read-only in various products, as there's no modification that can happen on such IPs. And again, this was also required to go through a full approval before they can be used by the design teams. And Hub provides us this additional feature or gateway before the IP gets published, to the Hub. And a special committee that is dedicated to approve or assigned to approve this IPs approves it as part of the flow, as shown here. An IP engineer publishing an IP, this Hub extracts the IP metadata, stores it, and the next step is the approval by the committee. Once that's approved, the IP gets published into the Hub. The corporate IP is what goes through the process, stored in the IP dev rep with release snapshots. The next is the community IP. These are the second type of IPs mainly developed by user community to be shared among same or different VUs as a starting point, in some cases as a fully reusable IP for their design work. So as you can see, a design engineer developing an IP publishes it to the Hub, it extracts the information, it's stored as a self-contained package and can be reused by other design community or within the same business unit design community. So Keysight HUB provides us the ability to reuse the IP first. It helps us, our engineers, to quickly find the IPs they need to use in their design flow. Next is comparing IPs. That's another key feature, giving us engineers to quickly figure out the right IP to use, comparing the similarities and differences by aside IP by IP. Finally, the reuse of IP in the projects. So using those IPs in their projects, the users or design community can customize them as or use them as is, improving or speeding up their design or development cycle. So as we mentioned in the previous slide, the corporate IPs are more read-only with release snapshots. They're strictly in read mode, so users can directly consume it without any modifications or not allowed to do any modifications. Community IPs, users can copy them to their projects or use them as is or modify them or update them for their project needs. So with these two types of IP and the Hub capability, we are able to leverage and improve our design cycles. To highlight, the Keysight offers the following capabilities. First one is the IP catalog. So Keysight IP management or Hub serves as a central repository for our entire collection of IP. This encompasses both internally developed IPs, corporate IPs, what we call, and also the engineering community IPs that are developed by the user community. By maintaining a centralized catalog, Hub empowers engineers to efficiently locate and compare relevant IP blocks for their IC design projects. Next is the IP comparison. So this allows you to compare a current IP with an existing version of an IP or a different IP to help users quickly to compare the differences between them and make an informed decision before consuming their IP into their design project. The third one is the IP specs. The IP spec capability allows you to have the information of the IP with respect to all the metadata. It can store the details about the IP functionality, performance, characteristics, history of the usage, and the current release information, making it very helpful for them to know where this IP has been used, traceability, and trackability as well. Finally, the project bill of materials. Hub seamlessly integrates with our design workflow, ensuring that all utilized IPs are meticulously tracked. Upon incorporating an IP block into a project, Hub automatically registers within the project's bill of materials. This centralized tracking mechanism offers valuable insights into the overall composition of each design and simplifies future maintenance and version control efforts. To summarize, with Keysight HUB IP management platform, we are able to achieve IP traceability, which simplifies meeting our ISO 26262 functional safety traceability requirements, tracking IPs to the projects. Bill of material is available, and also accurate and precise data sheets can be generated by use of any IP and project. And with the use of the streamlined IP management and traceability reporting capabilities, it helped us save an estimated 45 to 50% of the design time over the last 5 years. And finally, reviewing the system in place at Allegro, we have found approximately 55% of our community IPs are derived from pre-developed IPs, and it resulted in shortening our engineering lifecycle. And finally, we published a case study hosted on Keysight portal that goes deep into the Allegro IP management implementation. Thank you.